All right. So, our header, 1.10, cross multiplication. Again, I think this is a skill that a lot of us have seen before and even like tried to use in class. Sometimes it's the right time, sometimes it's not. That's fine. Our goal today is to know when is cross multiplication usable and when is it not. And so, if I'm thinking about number 1, I need to solve for x. Raise your hand. Do you remember the type of annotation that you use for cross multiplication? Do you remember the type of annotation that you use for cross multiplication? Janaya. Ooh, it's not left to right. Eden? So for cross multiplication, now I'm going to be extra. I have the ability to quickly switch between colors. I'm going to use 2 colors to make this very obvious where values are coming from. The annotations we make is we put a circle or an oval around 3 and 4, and we have another one around x and 5. And so I have circled diagonally on my fractions. These annotations tell me that I am going to multiply the numbers that are in each circle or oval, so each pair. So in the purple one, I have x times 5, and that's going to be equal to, and then in my blue one, I have 4 times 3. All right, well, raise your hand. X times 5, I'm really going to rewrite that as what, Carol? 5x. Thank you for raising your hand. And everybody, 4 times 3 is?
12.
There it is. And so I really have, right, 5x is equal to 12. From here, after cross multiplying, this is actually just a one-step equation. Raise your hand. What am I going to do on both sides? Ariana. Divide by 5. And so, over 5, we're going to have that x is equal to 12 over 5. And so again, that's a fraction that just needs to live like that. That's not reducible. Stays like that. Any questions on number 1? All right, flip your notes. All right, example 2, solve for x. Okay, raise your hand. How is example 2 different than example 1? How is example 2 different than example 1? Janai.
It's different because, like, instead on the left side, you got the x plus 3 over 5, and then the one in example 1 was just x over 3.
Good. Yeah. And so I wanna push our vocab a little bit. The x and the 3, what are those called? Starts with the letter T. Those are, all right, say it again. Terms. Those are terms. And so now I have 2 terms in my numerator, whereas in example 1, I only had 1. Now, that doesn't change our setup, but it is going to change how we approach one set of multiplication. And so I'm still going to make the annotation for the first one. That's 5 and 3. And going to do the same thing for the second one. The loop or oval might be a little more awkward because there's just more to get in there now. Now, the way that this is going to shift is that on the left, I'm going to have 2 times x plus 3 set up like this. Before I even write the other side, raise your hand. What am I going to end up having to do on this left-hand side? Ishan. I'm going to have to distribute. And so anytime we see two terms, I want us to know that we should be thinking distribute. That should be in our heads at all times for cross multiplication. Okay, well then on the right, I just have the one term, and so this is just going to be 3 times 5. Okay, well let's go through this. Distribute the 2. 2x plus 6 is equal to, everybody, 3 times 5 is. And from here, again, this isn't necessarily a one step, but it is just a 2-step equation. And so raise your hand. What am I going to do on both sides? Ashane. I'm going to subtract 6 on both sides. On the left, I'm going to get 2x is equal, everybody, 15 minus 6 is. Good. From here, one step away, raise your hand. What is my last step? Cairo. Louder. Divide by 2. And so x is going to be 9 over 2. Again, needs to stay like this. Now, I want to take 1/2 step back. Yes, the correct step is divide by 2. Why? Raise your hand. Why am I dividing by 2? Why? We want to isolate x. And so I'm actually going to push this. Why is it that when I isolate x, I don't divide by 7? Why don't I divide by 9? Eden? So hang on, say it again one more time, just louder. We're looking specifically at this step here. Why a 2? Why a 2? Aiden. Louder. Louder. It's our coefficient. Everybody, 2 is our coefficient. There it is. When we think about y, yes, I am 100% trying to isolate that x, but specifically y2 because it's the coefficient. If the coefficient was 7, then yeah, I would divide by 7. If it was 3, I would divide by 3. I always divide by whatever the coefficient is. Any questions on example 2? All right, then I want us to shift over to example 3. We are closing out notes. You have 2 equations. They're a little bit down below, so you can see A is x over 4 plus 2 is equal to 2x over negative 8. And B is 10 is equal to 15 over negative 5 plus x. You're going to take 30 seconds to yourself, and you're going to think about question 1. Can we use cross multiplication for those 2? Think to yourself, can we use cross multiplication for those 2? And so again, can we use cross multiplication for those 2? I'm going to add why or why not. Turn and talk. 30 seconds. Go. I'm going to come to you for that because that was very well said. Alright, and we're going to be back in 3, and in 2, and I need all eyes and voices off in 1, please. Charles, thank you, we're there. Far side, Zion, make sure I get eyes. Paolo, make sure I get eyes. We're there. Lewis, same thing, please. Ryan, thank you, we're there, we're there. Alright. Can we use cross multiplication? Why or why not? I want to hear from Ashane, please. Nice and loud.
You
Sorry,
can't
what's up?
use cross multiplication for number one because it's a fraction already, and even if you try to put a one underneath, it wouldn't be able to do cross multiplication. But for B, you can use cross multiplication if you put one underneath.
All right, and so a lot was said, and so let's zoom in. Do we agree that for B we can use cross multiplication? Yes. I want thumbs up or heads nodding. Yes. And as Ashane said, you put a 1 underneath the 10, and you are set up and good to go. As she started with, though, the issue with A, sorry, make sure I have eyes. The issue with A is that if we were to try and put the left-hand side over 1, we're going to end up with a fraction inside of a fraction, which A just doesn't work for us. But B causes, honestly, a whole bunch of other issues that we're just not super equipped to work with right now. And so if we're thinking about 1 can use cross multiplication, we can use cross multiplication for B, but not for A. We can use it for B, but not for A. Is that a question?
Yes. Okay. So I was thinking for number A, it was probably we could if we did more work to it, added the 2 to the x, and it would have been 2x over 4, and then it would have been 2x over 4 equals 2x over negative 8, and then we would have been able to cross multiply.
So I like where your head is at because Janaya is correct. A little bit. I'll say a little bit correct. We can make sure I have all eyes, voice off. We will be able to cross multiply. However, to Janaya's point, it's going to take work. Now, again, we have the right idea of trying to make 2 into a fraction. Exactly how we get there, steps are going to be a little different. However, we're already thinking about that. And so, before we actually show how, I want us then to think about how do we know when we can or can't use cross multiplication? Well, let's think about this. On B, we could quickly put a 1 under the 10 and it was totally fine. On A, it's not that simple. And so what does A have that B does not? That stops us. Janaya. The plus 2. This plus 2 is going to be the thing that is immediately stopping us from just going to cross multiplication. And so when we think about cross multiplication, the big key takeaway that we need, we can use cross multiplication when we have only 2 fractions equal to each other. We can use cross multiplication when we have only 2 fractions equal to each other. That 2 is going to fully throw off our game. Now, I want you to just write with me because I'm going to go over how we would do this, but I'm also going to advocate for the fact that turning this into cross multiplication is more steps than is necessary. And so, if I wanted to change this so that cross multiplication worked, the 2 is the issue. And so the 2 over 1 needs to be changed into such a form that we can combine it with the x over 4. In order to do that, I need common denominators. And so I have to multiply by 4 over 4 to get 8 over 4. Okay, well then that means that x over 4 plus 8 over 4 turns into x plus 8 all over 4. And so this is what Janaya was trying to say, where we need to get it written as one fraction. And so from here, yeah, I could reset up to x plus 8 all over 4 is equal to 2x over negative 8. And then cross multiplication would work, right? From there, cross multiplication would work. But if we remember the sort of spiel from yesterday, I've gone through and created a whole bunch of common denominators and like had to combine fractions. And I mean, you heard me say it yesterday, I hate fractions. And so if I came across something like A, I would actually probably just use LCM method that we learned about yesterday to just get rid of all of the fractions. What questions do we have on notes? All right, you have 1 minute. Use your glue stick, get them glued in. If you did not get a glue stick yesterday, your hand needs to go up. 1 minute, go.